Okay, so this one's talking about intersection and exclusion principles. So in your definition, when they talk about the union of two, okay, the definition, let's just quickly get it again. It says similarly the set of all elements in both A and B. So when they're talking about the union, they're talking about set of all. That's what's important, all elements, okay?
Okay.
So when they're talking about that, the union of A and B is obviously going to include R2 in this case, okay? But because they said it's a set of all elements in A or B, A and B, and set A and B, they're most likely discussing our R1 and our R3 too. In other words, they're taking up every section that has to do with A and B, I would imagine. All right, so similarly to that idea, when they said the union of A and B, it was obviously we had section A, because that is a section of A.
Yeah.
B, R3 is a section of that. R2 is where they both intersect.
Yeah.
But there's also other regions in this. For instance, R5. It doesn't intersect with A and B, but it is part of A. So R5 would fall under this category. Okay. Same idea with R6, just the reverse. Even though A doesn't intersect with B there, B is actually in that. And then obviously,
R7.
yeah, R7 falls under that too because it's where all things intersect. Okay, so that's the union of A and B. So the formula they've given you, let's make sure we write it out. The union of A and B is equal to all elements of A. Okay, so all of the elements of A, let's talk about them here. All the elements of A, we'll do in yellow here, are R1, R2, R5, and R7. Okay, so what we're going to do is we're going to put them in a formula. R1, R2, R5, and R7, okay?
Yeah.
5 and 7, 6, 7. Okay. With that same idea, okay, if we were to add all of those to all the occurrences of B, so all of the occurrences of B are actually R3, R6, R2, and R7. So again, what ends up happening is you get R3, I should have said R2 first, but that's okay, R2, R6, and R7. And what we'll do is we're just going to keep this, the intersection of A and B, out of it for now, and we'll talk about it. So if I were to add all those together, I would have R1, okay, check, R2, check, R2 again, check. Does this make sense so far?
Yeah.
R3, check, R5, what are the two that we're looking at? Okay, R5, check, R6, check, R7, check, and again, R7, check. Now what this states is the intersection, so we're subtracting the intersection. The intersection of these 2 points is R2 and R7. So what ends up happening is we cancel one out each. We cancel out one of the R2s and one of the R7s so that we don't double count a point. That's what that formula is trying to say to you.
Okay.
Okay, does that idea make a bit more sense?
Yeah.
So our answer is right. The union of them is all elements of A and B, including where they intersect each other. Intersection is only where they're crossing each other.
Okay.
Okay, so what they're talking about here is A is an element, okay, and C is also an element. It has its own. Now, what happens here is C is contained within A. Every part of C, so every part of C is actually a part of A. So in this case, C is then known as a subset of A. C is a subset of A. Okay, so now let's try to make sense of that question they've given us. Okay, so what they've done here is they've expanded everything. They are taking the first term and the second term, what they called their A and B term, okay, and they run it through. Theirs was, say, if it was to the 4th power. Their idea of this is you take your constant term from Pascal's, and you take the A term to the 6th. The B term is technically to 0 here. And then we add it to, again, Pascal's second level here, a to the 5th, b to the 1, okay? And we continue this pattern as we go through. Now what they're looking for is the last term, which is the constant term essentially, what they're going to be looking for here. Or sorry, in this case it probably won't be the constant term because our variable is our b. So they're going to be actually looking for the first term. We have to figure out what the number is going to be in terms of Pascal's, and it's most likely going to be a 1 in this case. So if this is our 1, what's going to happen here is the constant term means we're going to be multiplying 4 to the power of 4 multiplied by 1 over x to the power of 0. This is just our constant term, okay? So essentially, we're only dealing with that part of this equation here.
Yeah.
The rest of the stuff, we're not dealing with any of those other exponents. There's a lot more to that, okay?
Yeah, because it just goes down.
Exactly. So 1 over x is going to be our 1, okay? Assuming we're in the first row of Pascal's triangle, we're set with 4 to the power of 4, okay? We bring up a calculator. 4 to the 4th power is 256. So our only arbitrary number right now, 256, is Pascal's triangle. We're going to have to just quickly check to see the row we're in. So the first term is going to be 1 in this case. So our 4 to the power of 4 is going to give us 256. Okay.
And that was one of the answers.
One of the answers? That's
Yeah.
what we're looking for then when we go through that. So these are all our options. In terms of starters, they say there's going to be 1 starting center.
Yep.
How many starting forwards?
2 starting forwards
2 starting
and
forwards?
2 starting D.
2 starting D. Okay. So the idea to this is his very first choice. Say he starts with his centers. Okay. His very first choice is he has an option of center 1 or center 2. From there, he has the option of 1, 2, 3, 4 guys. 1, 2, 3, 4 guys. Okay.
Yeah.
Once he chooses one of these forwards, he only has the option of how many more forwards?
Oh, he has the option of 3 more forwards.
3 from each of these spots, okay? So this is the idea, I guess, here.
Yeah.
Try to fit them all in. Okay. And then from there, he wants 2 defenders. The same thing happens. He has 4 and then 3 as an option.
Yeah.
So in terms of the multiplicative rule that we looked at before, he has 2 options for his center. Okay. So well, in terms of how many, he has to make 5 picks in general, right?
Yeah.
He's got to pick 1 center, 2 sets of forwards. Okay, so those are our forwards. And then he has to choose 2 sets of defenders. Okay. So, and what he has in terms of choices is he has 2 centers to choose from. Then his next pick, he has 4 forwards to choose from. Then he only has 3 forwards to choose from. Then from there, he has how many defenders again?
4 defenders.
4 defenders again,
And then 3.
and then another 3 defenders again. And then, in terms of double counting, we subtract our 1. So in our calculator here, his options are 2 by 4 by 3 by 4 by 3. Subtract 1. So 288. Subtract the 1. 287 options in terms of how many different ways he can put his team out onto the field. They say they want at least 1. Okay, that's an important term.
Yeah.
At least 1 piano.
Yeah.
Now, if they don't say anything about repeating, and we can use that same piano one over and over again, your options in terms of your permutations, we have C, we have 6 piano, and we need at least 1. Okay? Then from there, how many options do we actually have? Well, we have 18 options, right? Because it says at least 1. It's not restricting us to only 1. And it also didn't restrict us in terms of repeating. Now, if there was repeating, this number would only be 17, and they want 4 options of it, right? They want 4 pieces, so that's 1. They want 3 other pieces. So essentially, this guy here takes care of our first piece, while this guy here takes care of the other 3. Now, this is if it's not repeating. If it is allowed to repeat, the formula here is like this, and 18 to the 3 other pieces of music. And we would use these 2 formulas to solve it. So one of these two formulas is exactly what they're looking for. We don't know if they're allowed to repeat or not repeat. Okay, so we're going to try to solve it both ways. If they had said only, okay, that would change this. If they had said only one piano piece, then we'd have our 6 options, and then we would take piano out of this from there. And without piano, we have 5 recorder, 12 guitar. So I keep drawing 6s instead of C's. You're right, we would have 12 and then the 3 other options of music. But because they're saying at least, that means we can go in with more piano, right? So we have at least 17 options. And if we're allowed to repeat, then this is the calculation we're looking to use. Okay. So if this is our formula, let's say, in this case, we're going to say that you aren't allowed to repeat. So we use 6C1 times, without the repeating, is 17.3. So we put both of these formulas in here. C1 becomes 6, and we go to plug it in. 6 subtract 1 times 1. Okay, that idea. So when you go to put that in your calculator, so what we do from here, we're plugging this into our calculator, so then we don't have to do 6 times 5 times 4 times 2 times 1. We have that function on our calculator. So 6 here gives us 720, right? Mm-hmm. So we get 720 over 6 minus 1 is 5, and then times 1 to this.
Yeah.
Okay? 1 to that is 1, and 5 there is 120. So we have 720 divided by 120 times 1, which is just 120. Does that make sense?
Yeah.
Okay, divided by 120, we get 6. Okay. So there's our first one. All right, we're going to have to multiply it 2. Now our other option here is 17. Okay, so C17 to the 3 gives us 17.
I got 680.
680? Okay, let's double check. To the 3 times 3 to that. Okay? Mm-hmm. What did you get for 17? Just off the top, if we do this one step at a time. 17. Oh my gosh. Let's try to simplify this a little. We'll do the bottom part first. That way we don't have to write it all out. This becomes 17 over 14 and 3. Okay. We can probably do that all in our calculator. When you get it, what did you get?
Oh, for the whole thing, I got 680 as the answer.
680?
Yeah.
Okay, so when we go to plug it into our formula here, get our answers down here. Remember, our options were equal to C61 multiplied by, I keep trying 6's, C17, 3. C61 was 6 times our 680. Our options are 6 by 680 equals 4,080 options. Does that make sense? Mm-hmm. That's if they don't double count piano, okay? Mm-hmm. So let's say don't. If they do double count piano, we get C61 times, do you want to solve this one quickly? C18.3.
I got 816.
816?
Yeah.
Okay. So 6 by 816, 4,896. So if they're allowed to use that same piano piece twice, it increases it by almost 800 different more options.
Yeah.
Okay. What we'll do is we'll expand this in order to try to figure it out. Okay?
Okay.
So we have our first option here. The next option is C7. Actually, it was C0, right, to start?
Yeah.
C0. Next one is C1. Same idea. AX to the 6th, BY to 1, right? Next one would be C7 2, oops, AX to the 5th, BY to the 2nd. Okay. We can continue on with this, right? We can go all the way down to the 7th different term in here. But in your question, what they've said is the coefficients of the first 2 terms are 128 and negative 224. So what they're saying is, assuming they're discussing, this is our first term, and this is our second term here. Okay?
Yeah.
So what we can do is we can clearly solve for, using our formula from before, we know that C0 is going to give us 7th to this, divided by 7 subtract 0 to this, and 0 to this. Pretty sure it's going to give us 1 in the end.
Yep.
Let me just double check. Yeah, that still gives us 1. In the end, it's going to give us our number 1. Okay. The other one we're going to need to solve is C at 1. Okay, because this one was from our first term. This is from our second term. So C to this from 6 to 1. What's that going to give us?
7.
7. Okay, so in our formula, now we keep going. I'm just going to focus on the first two, okay? We're going to leave out the rest. C here, we can replace with 1 times ax to the power of 7. By to the power of 0 is going to be what?
0.
Not quite. Any number to the power of 0?
1.
Yeah, exactly. It was going to be 1. So we can replace that with the number 1 also, okay? Plus our C and 7, 1 there was 7, and we're left with ax to the 6th, by to the 1, which we don't really need to include here, so we've got that at all. Okay, so like we said, they've given us information for just the first two, so we're just going to focus on those two. We solved for our C's, so we got that, which are 1 and 7. And then in this question, they told us the coefficient of the first term, so this is essentially our first term, was 128. And the coefficient of the second term was negative 224. Okay? Now what we're going to do is we separated our variables. In the very first term, we knew that by was just going to be equal to 1 because it was set to the power of 0. So we actually got rid of the y variable.
Yeah.
We set this just, we split up the a7. A to the power of 7 is going to be our coefficient. And x7 is our variable. We don't know what x is going to be.
Yeah.
In the second one, x and y are both our variables. And a and b and 7 are part of the coefficient.
Yeah.
So there's a lot more to solve in the second one, so we focused on the first one. Okay? When we focused on the first one, we actually knew since there's only a to represent the coefficient and x represents a variable, it was actually pretty straightforward. We knew 128 was going to be equal to this a to the power of 7. Okay? So a to the power of 7 was equal to 128. We found the 7th root of both sides. A is now 2. Okay? Now for the other one, what we can do is we know our coefficient here is 7. A to the 6th, b1 is equal to what?
Negative 224.
Negative 224. Okay? Now I have two variables here, but I've actually just previously solved for one of them. We now know that a is equal to 2. So I can replace the a in this equation with the number 2 since we know that. So I'm going to do the rest in black here, okay? 7, and the a we'll do in red. 2 to the power of 6 plus b. We don't need to include the 1 because it's the same as just having the next one. Is equal to 224. Okay? 2 to the power of 6. It's a 64, I think. 2 power of 6. 64, yeah. So we get 7 times 64 times b is equal to negative 224. We'll have to do 7 times 64, so times 7, 448. So we get 448 times b is equal to negative 224. And our goal is to isolate b, so we'll have to divide both sides by this number. 448 divided by 448. Looks like it's going to be a half in the end. Oh, terrible. There you go. So when we isolate for our b, we end up with 224 negative divided by 448, negative 0.5, or a half. So you get negative a half or negative 0.5. So in the end, our answers are a is equal to 2, and b was equal to 1/2 as our answers. Okay, let's turn it black.
That's fine.
That's good. Does that make sense?
Yeah.